The floor is yours.
Thank you, Professor Casanova, for inviting me, thank you very much for the introduction. So let me just share the screen. Share. I think you can see my screen, correct? You can see my screen? Okay. Good. So, boa tarde, everyone. First of all, I have to apologize. Sto un poco ingrippata, so sorry for my voice, it's not the best. So my name is Chiara Renso. Like Raffaele last week, I'm from National Research Council of Italy in Pisa. And today we discuss about the challenges for mobility data, specifically for the integration, the sharing, and the analysis. So my name, as I said, is Chiara Renso. I'm a senior researcher at CNR in Pisa. And as Raffaele says last week, National Research Council is a huge research organization in Italy with different disciplines. And we have more than 8,000 employees in total. And we are from ISTI, which is a computer science institute located in Pisa, in Tuscany. You probably know Pisa for the Leaning Tower. And our institute is part of a huge campus in Pisa. You can see in the picture here in white. We have several institutes from several disciplines, like medicine, physics, optics, neurophysiologist, and so on. And we are the largest institute of computer science in Italy, in National Research Council. Again, these slides also was similar of Raffaele last week, but my slides are better, so I repeat for you. So we are part of HPC lab. Lab is a lab inside the ISTI Institute, and the name of the lab is Icon Performance Computing. Raffaele Perego, who presented last week, is the head of the lab. And essentially in our group, we study large-scale distributed system, cloud system. In general, we focus on the efficiency, information extraction and retrieval, big data analytics, machine learning, artificial intelligence, mobility analysis, information extraction, and semantic enrichment. So today I focus on these last two things, so mobility analysis and semantic enrichment. Here you can see the link of our lab webpage, so feel free to go and discover our topics. Again, I have a similar slide of Raffaele last week, but mine is more updated. So here you can see the people who now is part of the lab. So on the left part, you can see the senior people, and in the right part, you can see the younger, the PhD students. So you can see we are a big group, and maybe you can also notice we have two students, also Brazilian students. So we have two students in Cututela from the Federal University of Santa Catarina in Brazil, Fernando and Bruno. And okay, so we are a big group and we work on this topic that we discussed before. Okay, so the agenda for today. So I will start with introducing what is mobility data, what we are talking about mobility data, and why we are sharing mobility data. So we first discuss mobility data, then the issue of sharing mobility data, why is an issue, why is a challenge. Then we go on mobility data representing as trajectory is one form of mobility data. So we discuss why we are discussing about trajectories of people or other objects. Then we focus more on my research, let's say, topic, research result on multiple aspect trajectory creation, representation, and analysis, and why this is important for mobility data sharing. And then we conclude with some challenges that are still open in the research community about challenges of mobility data sharing, and especially specifically the use of generative AI for mitigating some of these issues. So let's start with what is mobility data. So when I was wondering how can I define mobility data, then I asked ChatGPT. Okay, so I asked ChatGPT, and here you can see what I could see, 3.5 version. So ChatGPT says that mobility data refers to information that capture the movement pattern of people, vehicles, or goods across various location and time. Data is typically collected like from sources like GPS, mobile phone, transportation system, and many other kind of location technology. And the mobility data is used to analyze individuals or objects while moving, which routes they take, the duration of the journey, and frequency of the movement. I more or less agree with this definition. So let's take this for good to go to definition. What I have to say is written below is that this definition essentially refers to human mobility and goods. Sometimes use mobility data also to refer to other field, like animal movements or vessel in the maritime domain. So let's think more in a general way. Then ChatGPT says that we can use mobility data for several application domains. Here he lists 5. It's not only those one, but it could be a starting point. So urban planning. So to help, see if we know how people is moving in a city or vehicle are moving in a city, we can understand how to design better infrastructure, optimize traffic. And I know that in Rio, we have this huge problem of optimizing the traffic. Improve the public transportation and so on. You also have the experience of COVID, so the study of the epidemiology, so how people move also can affect how the disease are spreading, marketing, environmental monitoring, of course, and transportation organizations, so for logistics, for example. Uber, if you think about Uber is using an algorithm to optimize the path from a starting point to a destination based on the traffic and based on the price you are going to pay. Then ChatGPT said we have again 5. You know, ChatGPT goes for list. So he listed the 5 key resources of mobility data. So the most common use is GPS that we have in our telephone, whatever. So a smartphone, wearable device, something like this. Mobile phone also is a source of mobility data. All transportation system service, so the ticket we pay entering the bus or the metro, ride sharing services by sharing metro buses and so on. Social media also with the geotagged post. This is less common nowadays because of the different laws that make this more difficult. But in any way, we can still allocate social media posts and all kind of smart infrastructure like sensor, camera, and different kind of monitoring tools. Something that is very important when you talk about mobility data is privacy. Mobility data can be sensitive because if we know where people is, we know a lot of personal information about this person. So for the different laws in Brazil, in Europe, and in other countries as well, location data is sensitive, is a sensitive data. And so we have to be careful about the privacy, that privacy can be disclosed in case of location data, if we know the location of a person. So having early access to mobility data pose a high concern of privacy risk. So what we do usually is to anonymize this data. So the location data we will see later is a data that can be anonymized. There are different algorithms and methods to do that. And with anonymized data set, we can still do some analysis in these data sets in a privacy aware way. Okay, let's focus on the key sources of mobility data now. So I copy here. So we did already discuss GPS device, mobile phone, transportation system, and so on. What we notice here is that these different kind of sources of mobility information, they can come from different data collectors or producers. So we can have GPS device coming from an app, for example, installed on the telephone, let's say Google or others. We can have mobile phone coming from the telephone provider. We can have transportation service coming from the car that we use for the metro. social media, and so on. So they all come from different data collector or data producer. And this means that the mobility data can have different kind of mobility data, and they can be, let's say, collected and stored at different actors or producer of this data. And then we go to the second point, which is sharing mobility data. Sorry, interrupt a little bit to say if you have any question or something is not clear because of my voice in gripada, please interrupt me at any time. And I'm not sure I can see the chat now because I'm projecting, but you can just interrupt me. Okay, second point. So now we know it is mobility data in general. So why sharing mobility data? So sharing is possible. Sharing means the different actor can give this data to some other actor. So it can be the general public, can be another data producer, can be a data analyst or whatever. So share means that I collect this data and I want to share with someone with some conditions. So sharing is possible and is very important for some application, as we will see later. And here the recent experience on this project, European project called Mobi Data Lab. Let's see. So again, it is a repetition a little bit. So why mobility data sharing? So there is a huge quantity of data that is collected every day from hundreds and thousands or millions of data collectors, okay? So it could be the transport company when we pass the metro card, can be our apps, our Fitbit, or whatever. So all these data collectors, they own all this data and it's a huge quantity. And so we have different data producers and different data sources. If we can share, if we can convince this collector to share this data, then we have an enormous possibility of propose new method, how to integrate this data, how to create value from this integration of different data sources. In Europe, I'm not sure how it is in Brazil now, but in Europe, we have the European Commission is investing a lot on this data sharing culture. So what they want to do, putting a lot of money, a lot of effort on this topic, is to create this, what they call data sharing culture. So it means to convince the data producer, could be mobility, could be another kind of data, to share their data. So they are collecting the data, but the commission was to create this environment that favor the data collector to share the data with other data collector, other data analysts, and service provider as well. So what they're doing here, I put here a screenshot of the European Commission. They say they want to create a strategy to put in people first in developing technology, as you can see, and they want to create this sharing culture, okay? One of the point, again, they put 5 points like ChatGPT. In the 5 point about healthcare, of course, very important. And then the second point, that creates safer and cleaner transportation system. So mobility data sharing is also very, very important for the European Commission. They are investing, I say here, aggressively investing. So they put a lot of money, a lot of effort, try to create an environment in Europe so that people, the company collecting data, they are more keen on sharing this data. So why they're investing so much money, public money, on this topic? Because sharing data is not so, let's say, obvious as we can think. So we have benefits of sharing, but also issue of sharing data. So it's a kind of trade-off that we have to find in this tension of these two extremes. Okay, so the benefits of sharing, but also the issue of sharing the data. So I'm collecting the data. I have data also could be private, sensitive for the privacy of the citizen that I'm collecting from the individuals. How would I share this data? Why should I share this data that maybe I collect with a lot of investment of money from my side? So there are benefits and issues. Benefits, which could be some benefits of data sharing. Okay, more potential application. When we can combine data, we have more possibility of novel application. Okay, so if I only have, I don't know, the ride sharing data, for example, for the bicycle or the patinette or whatever you think, having only this data could not be enough to optimize, for example, a prediction algorithm. So if we have, for example, the weather data, or we have the metro data, the bus data, or the tourist data, then we can have a better prediction of when and where we need more bicycle or patinette or cars in the case of taxi or Uber. So the number of potential applications is more or less infinite. And this is one of the main reasons the European Commission is putting so much money on this. So novel applications. New business model, okay? Because if a company is sharing the data that they invest a lot to collect, they need a business model to return of investment of this money. So we are creating also new business model around this. Of course, more meaningful analysis result. So as I mentioned, maybe to predict or to analyze the behavior of people in a city, we have more data that are, let's say, orthogonal, one is the other, then we can have a meaningful analysis to better understand how people is moving in a city, for example. More accurate prediction, for example, for traffic, transportation, recommendation for tourism. So I can recommend tourists to go to, I don't know, Ponta Sucar, but then if I have information about, let's say, the strike of transportation, I can recommend to use Uber, or the contrary, to use Metro because it's too traffic. So the more information we have, we can collect and combine all together, the better will be the recommendation or the prediction or the analysis algorithm that we are running. More transparency, explainability, of course, so we have more information, we can be more transparent and to explain better our decisions. We can think about other benefits, okay? So this is the main one. I did not ask ChatGPT, just from myself, okay? Issues. Okay, so it's not only gold, what we see, there are other problems. Could be a problem. As I mentioned before, privacy. Okay, so even if I collect a lot of data, like Google, for example, I really cannot share this data because of privacy laws. In Europe, we have GDPR, you have the lei, I don't remember the number, you have in Brazil that is more or less similar to GDPR from 2021, GDPR is for 2018. And this protect the individual in terms of location data. So we cannot, the data collector cannot share your location data without your consent. And this is a big obstacle in sharing the data when they refer to the specific individuals. So we have to create anonymization of this data. For example, if we anonymize, then we are more keen on sharing this data because the privacy of the individual is less affected. Confidentiality, of course, if I'm a company like Google, I'm collecting data, I don't want to share this because of this is data that I have inside my company, my business. Of course, data collector and service providers can be worried to lose competitive power because Google has all this data about us. And if they give to someone else, then they can lose some competitive power in the market. So this is something to think about when we share the data. Something also very important is the different legal frameworks, so the data ownership. So if the data is mine in a state, then I share with someone else. I have to understand which are the legal implications of this if this someone else is from another country. So the legal point of view is very, very, very complicated from this point of view. So how can make this effective? So this too extreme effective. So this is what we did in a European project, financed by the European Commission. I just finished it some months ago. And here the idea was to develop methodology and tool for increasing data sharing cultures, okay? This is the link to the project in case you are interested to know our result. But what is important is that our idea was to prototype a new mobility data sharing solution, okay? And essentially, the concept of the project, I'm not going into the detail, of course, but what I want to emphasize here that we envision 4, let's say, aspects or direction to follow all at the same time. So, of course, we need to know all the legal and regulatory laws that are around this problem of the data ownership when we exchange data that is mobility data. So problem of governance, problem of standards, because I can share data, but if it's not following a standard, the other actor cannot understand what I'm sharing. So market analysis and so on. So one aspect of the project was focused on this specific topic. Another very important aspect is produce a prototype. So let's try to see what we can build that can implement this idea of mobility data sharing. And this transport cloud prototype, where we can collect and combine all this public transport data, road data, weather, pollution, tourist data, any kind of data that we can think can be combined once it is shared. Of course, we put into practice this exchange. So we developed this, what we call virtual lab. So essentially it was a number of hackathon, datathon, to experiments with practitioners and startups, innovators, people from companies, students, also some students from the University of Pisa won this prize on this hackathon. So the idea was to try to put this together and have people to experiment in a programming environment. And of course, to study all the social implications, especially, for example, new business model, intellectual property, and several other aspects that we need to keep in consideration when we are in this environment of sharing the data. Let's focus a little bit on Transport Cloud. Transport Cloud, again, I'm not getting the detail of this, but the idea is that this prototype should have this component. So it should be a federated cloud. I don't know if you're familiar with the terminology, but the idea is that it's a federation of infrastructure that can communicate with a federated identity. We have a data catalog, some service to access the data. Of course, privacy, as I mentioned before, is a very important part. So we have a lot of anonymization algorithms included. And then we have what we call processors. That is how to combine this data. So we have the data is available through this infrastructure. Now we want to create value of in the combination of this data. And among this processor, we have what we call semantic enrichment processor. And this is what I was working on. What is a semantic enrichment processor? Essentially, the semantic enrichment processor is a way to integrate mobility data that with trajectories, for example, we will see later, with semantic information coming from different data sources. Again, we are in a data sharing environment, so we have a way to have in the same, let's say, infrastructure platform, different kind of mobility data, contextual data, and we want to combine this in some way. Something that we also want to do is to have access to the linked open data. I don't know how much familiar you are with linked open data. Anyway, the idea is that with linked open data, we can combine data coming from different data sourcing in a uniform formalism, okay? So now we are in the third point. So we understood what is a mobility data, why it's important, and which are the issues of sharing mobility data. And now I want to go a little bit more in deep on mobility data intended as trajectories. I don't know if you have any question this time. I don't see the chat.
I have a question about, you said that there is an European organization that's trying to incentivize people to share data and that is investing a lot of money. And you also showed the lab project, but it's not clear to me how exactly they are convincing the companies to give up their precious data, and what exactly this money is going to. Is like advertising, or they like literally
So
buying
when
data?
okay, no, it's a very long and complex. Thank you for the question. It's a very long and complex answer in the sense that the European Commission is investing money in the sense that, for example, in our case, they fund a lot of projects where the topic is to find a way to convince company to share the data. Okay, so exactly your second question. So how you convince a company to share the data? What we did in our projects, that is a small project, but we have other projects in the commission, is to prove with some experiment with the hackathon, datathon, so trying to have some small prototype, more experience with this data to show that the added value in terms of novel applications that you can build, thanks to the fact that you put together the data, is an added value for the company. So if you can sell a service that is a novel and is new compared to what the competitors are doing, you have an increase in your gain. I don't know if I answered your question. So the commission is putting a lot of money in terms of funding projects that try to find solution to how to convince the company to share the data, which had advantages. So study solutions, also because we use this federated, I didn't went into the detail of this federated architecture, but I can send you the link. It is a way to use the federated architecture for the data collector to keep their data in local and only share with API, for example. So there is no way that the other can just take the data and disappear. So we have different technical solutions try to mitigate this the issue.
Okay, no, this answers the questions. Thank you.
Thank you. Thank you for your question. Other questions for this part? Okay, but feel free to interrupt me, okay, if there is something not clear. In this part of the architecture, I really didn't went into detail because it was not a topic, but you can see in the slides, then there is all the links. So if you're curious, you have all the information. It's a long way, okay? It's a long way from what we are now to the ideal world where everybody share the data. But we can do some step by step. We can have it later. Okay, go back to our presentation. So mobility test trajectory, which is the idea. Again, remember that we are talking about this semantic enrichment processor, but the idea is general. It's not only about the architecture, it's how to combine this data that is representing the mobility of an object, a person, for example, come from open data, for example, or data from Google or another company that want to share, and how we can combine, and which is the added value that we can get in this with this data. Okay, what is a trajectory? Again, it's I think 20 years I working about trajectories, but this time I asked ChatGPT, what is a trajectory? So among other things, the usual list of 5 things, I just extrapolated the 2 that I can agree more. Okay, so he says, ChatGPT says, in geography and mobility study, so it's more in a conceptual point of view, he says trajectory represents the movement of a person, vehicle, or other moving entity across a geographical space, often recorded using GPS or other location tracking technologies. Then we go to a definition which is more computer scientist, data analysis. So a trajectory can be a sequence of data points representing the position of an object or an entity over time. Trajectory data is often used to study human mobility, animal movement, and transportation patterns. So as I already mentioned you. So it's a way to represent the movement of an object that moves in space and time. So here we have a representation of what we call a road trajectory. So it can be a person, a car, a train, a vessel. And essentially these points, black points, are the location, the spatio-temporal location. So whenever you use a GPS or a IS system in a vessel or any other location device, we have this information that you see here. I don't know if you see my mouse. We have the ID of the object, X, Y, which are the coordinates, the geographic coordinates, latitude and longitude, for example, and then we have the time. That could be the date and the time, for example. So here we see an example of what we call road trajectory. So it's only spatial-temporal trajectory. So we have a sequence of points as we collect from GPS. I don't know if you ever tried to use GPS to collect your trajectory, like in Strava, for example, or other application. You see something like that. If you plot in the map, you can see something like that. If you see below, I don't know what time is it. I am 9 minutes late in my plan. So I say Chiara, for example, is in this location that is Latin log. I can tell you that this Latin log corresponds to PUC. This is the date, it's the 10th of September and 1:30, for example. So this is one point, okay, of the trajectory. If you have a sequence of this point, we have a trajectory. What I put also here is the trajectory segment. Trajectory segment is a part of a trajectory, okay? It's a sub-part of a trajectory, it's a small part of a trajectory. For example, here we can go a segment from this group of points here to this other group of points. So this is a road trajectory. Then in the literature, okay, some example, okay. This is a trajectory that if I had come walking, that was not the case this morning, this would be my trajectory. I start from Plaza Osorio and then I come to PUC, okay? So this could be a trajectory of a person walking. We have other kind of trajectory. So this is also a trajectory, the display of a trajectory that you see these people moving in, I don't know in which city, that they draw something with the trajectory. Okay, so there is a dinosaur. So there are a lot of people, I discovered that they go around with the GPS to make drawing out of the trajectories. You can have some fun in these drawings. Then we went a step further in the literature. So after road trajectory, as I showed you before, you see something like that, okay? Chiara, 22:43 is no meaning. If I didn't tell you it's PUC, you didn't know, okay? You just see Chiara, number, time, you don't know. So what we did is to create what is called semantic trajectory, so stops and moves. So essentially this trajectory is a trajectory that is annotated with some semantic information. So for example, here we see Chiara, Clara, that is stopping. You see many points here means there is a stop. So I was standing still and I was stopped, for example, in hotel at 1 a.m. Okay, then I go by bus, for example. So I have another segment, part of a trajectory, which is a move. Then I can stop again, and then I can go walking for jogging, for example, in Ipanema, and then I have a move. So my trajectory that before was just a list of numbers, now becomes something that is more meaningful. So I know that I stop in the hotel, then I move by bus, and then I move by jogging, for example. So in this case, each segment is enriched with a semantic label. So we know that Chiara was stopped in a hotel, Pagabana, for example, from 11 to 12, and then Chiara moved by bus from 12 to 12:30, for example. So this is another way to represent the movement data. It's more semantic based. That's why we call semantic trajectories. Then we went one step further. with this paper that you see here in 2018 with our Brazilian colleagues, where we went a step further. So we say, okay, the semantic enrichment is not only the label, but is a more complex object. So what we do is to enrich the segments, so the part of the trajectory can be stop or move, with more complex information. So here, for example, we are an extreme case, of course, but we can see that a person is stopping at home. We know from the Fitbit that is sleeping, for example, 78 is the heart rate. Then we discover he was working and the weather was sunny and the heart rate was 92, and then he posts something in the social media and so on. So then later the weather become cloudy, and then he stopped in a museum, for example, and the pollution was very high or something like that. So we imagine something where the road trajectory, the points, is enriched with a lot of semantic information, very complex semantic information. Imagine if I stop in a restaurant, then I can think about TripAdvisor or the rates, the price, the opening and closing time, and so on. So we create what is this multiple aspect trajectory. So as trajectory with a lot of heterogeneous aspects, semantic aspects. Again, I go back to the data sharing. Why we can imagine this trajectory? Because we can access in this ideal, let's say, vision of data sharing, we can access all this data, okay? The weather data provided by the meteorological company, the restaurant data for TripAdvisor, for example, the Facebook, and so on. So in this ideal, let's say, vision of data sharing, we can imagine that we can collect a lot of information about the movement data. This multiple aspect trajectory is it was at that time a new kind of data. So we introduced for the first time. And so we have to ask ourselves how we can create this data set, how we can manage this kind of data, how we can infer interesting knowledge, which kind of application, again, go back to the data sharing. If we find a good application, then we have a good motivation for company, the actor, to share their data. So it's important to imagine which application can benefit from this multiple aspect trajectory. The trajectory can also be big data. Okay, if you're familiar with terminology, means a wide variety and huge quantity of this data. And of course, the privacy. Don't forget the privacy of individual that should be keeping in consideration. Okay, any questions so far? Should I continue? Okay. Let's continue. Sorry, just a moment because it's continued beeping. Okay. Okay, so let's go a little bit in deep on multiple aspect trajectory. And this was when we invented this kind of trajectory. It was in the context of another European project that I was coordinated at that time, that we call MASTER, Multiple Aspect Trajectory Creation and Analysis. This project, as you see here, you have the link if you're interested, you're curious. Ended in December 2023. This was a 6-year project. And if you see the map, it's quite small, but if you can see the map, the partners of this project, one of the part of this project was PUC, Professor Casanova here. Then we have University of Ceará in Fortaleza and University of Santa Catarina, still in Brazil. Then we have Canada, and then we have a number of partners in Europe. So during this project, what we did was a project that funded the travel in between Europe and Brazil and Canada. So me and other colleagues came here, went to Canada, went to Santa Catarina, went to Fortaleza to work with other colleagues on this idea of multiple aspect trajectories. So which was the idea? As you can see here, essentially during the project, we aim to develop methods and application. Again, remember, application are important to understand if and how data sharing can be useful and can convince the actor to share their data. So the methods means how we can build these new data sets, how we can infer knowledge from this, how we can preserve privacy. So we work at the definition, construction of this multiple aspect trajectory or holistic trajectory is the same. We develop method for the analysis of this data. In both cases, take into account that could be big data, and also take into account that we could have privacy issues when we share this data. And the application that we were working on was transportation, sea monitoring, and tourism. Again, I'm not going into detail. It's a 6-year project, so it's not now the time to go in detail of exactly what we did. But just to have a table in case you are interested, and you can go more in deep about this topic. So how we create and manage multiple aspect trajectory. The first challenge, we developed some methods that you see here, cited in at the end of the slides. You can find all the reference, of course. How we can infer interesting knowledge. Also, in this case, we develop several methods to analyze this multiple aspect trajectory. Which application? Here we work with the Santorini Island for studying tourism. We had the maritime study with the trajectory of vessel and transportation analysis in Venice. Also, we study methods for big data. So when this data is a huge quantity, and the privacy and the ethics of using this data. Then I want to focus on three of these papers, which are the papers that we were working on recently. For all the rest, I give you the link to the publication. We have several publications, so if you're curious, just go there and look. Why I focus on these papers? So because we focus on the first research challenges, which is how we can create and manage multiple aspect trajectory. So one of the first questions that we did to ourselves at the beginning was how we can create this data set. So I imagine that we have this data shared somehow in the platform. So how we create this new form of data multiple aspect trajectory. So what we developed is a tool called Math Builder. It essentially is organized like this. We have three. We start with the row trajectory. Remember, row trajectory is x, y, t only. Okay, so latitude, longitude, and time. So we start with the row trajectories. Then we apply 3 steps. That is pre-processing, segmentation, and enrichment. We take data sources, what we call enrichment data sources here, is data sources containing contextual semantic information, the aspects, okay, the semantic aspects. Could be from the transport cloud, could be from external data source, whatever you can imagine. If the data are shared, then we can use them. Here we have to find a way to include them in our tool. And then the output is a multiple aspect trajectory. So we can have the stops, we can have the transportation mean, we can have the weather, we can have the POI, point of interest, where people stop it, and so on. So here is some screenshot. I don't go in the detail of the tool, but just to show you which is this process. So we start with the pre-processing. Pre-processing means to let's say pre-process the trajectories, make the row trajectory usable for the enrichment. So essentially, here we detect the noise. You know, the GPS sometimes has these strange points far away. So we clean the data essentially. So during this step, we clean the data. Then the second step is the segmentation. If you remember, we talk about the segmentation of trajectory, the segments of the trajectory, because when we enrich the segment. So it can be a stop, a move, the tell, whatever. So we need to identify the part of the trajectory that we want to enrich, to give a label, to give the semantic information. So essentially in this step, we give the parameter for the segmentation, so how we want to divide the trajectory into segments. For example, minimum duration of a stop, 10 minutes. So to be a stop, should be stopped somewhere for at least 10 minutes, and so on. After we segment, we can enrich. And this is the most complex task, because here we can decide we want to enrich the move. For example, I move from one place to the other. I move by what? Uber, taxi, walking, metro, bus, and so on. So we can enrich the different part of the trajectory, segment, stop and move with different ways. For example, the stop we can enrich with the POI, point of interest. So if I am analyzing the stop Chiara here, probably the closest point of interest is Spook. Okay, but if I am Plaza Osorio, I have several point of interest around. So I should choose which is the most likely point of interest I'm visiting. Social media posts, for example. So if you have my Facebook or Instagram, whatever, we can enrich with the social media, weather information. Today, fortunately, is sunny here. So, and so on. And we can combine together. So identifying the segments to enrich and how to enrich with the information in this interface. Okay, so you can see here the screenshot. And something that, what time is it? Okay, something that we were working on is that is already here in the last line here. So what do we want to do to make this even more shareable than before is to save this multiple aspect trajectory. Once we combine all this data, we want to save in a format with this RDF. I don't know how much you are familiar with linked open data knowledge graph, but I give you the keyword, then you can go more in depth to study this better. Anyway, the idea is that if we have a representation, it's a formalism that we can represent the multiple aspect trajectory, so the road trajectory, the segments, plus all the semantic information, then we can enrich more because we have a linked open data. So we can link with other data that is openly available, like Wikidata, Wikipedia, and so on. And so what we did is, starting from the data to enrich the trajectory, the data to enrich the trajectory, we use Math Builder to combine this to create a multiple aspect trajectory here in green. Then we save this as a knowledge graph, RDF essentially, and then we make this available with API and Spark endpoint. I don't know if you're familiar with that terminology, but just take this as the idea that we want to make this even more shareable. Okay, because it's not format that can be easily shareable with other or linked open data sources. I think I can go quite fast in this part. I don't know if you have question. Just a second. Do you have questions so far about the semantic enrichment? Questions?
I have a question.
Yeah.
You said that we have data from multiple actors, and it's important that they share the data with anonymity. So they must anonymize the data before
Yeah.
to ensure privacy. So how can you combine data from different sources if they are all anonymized? How can I know that this person that walked on the streets, the same person that posted this thing on Instagram? How can we merge the data?
Yeah, this is a good question. So again, I didn't go into the detail of the privacy part. It is another seminar if you want. But essentially with the privacy, there are different ways to make the data private, okay? So what we saw here, sorry. What we saw here in this multiple aspect trajectory here, you mentioned to this picture, no? So
Yes,
what happens?
yes.
So if I anonymize the data, of course, we have a trade-off, okay? So we cannot, let's say, have the data specific but I can still have some enrichment. So for example, some privacy algorithms, they tend to change, for example, or to change the points, for example. So if my trajectory now in PUC want to be anonymized, they can fake the points not to be in PUC, but I don't know, in another shopping mall somewhere, okay? So the idea is that I can still have some utility information, but anonymizing the data, okay? So it's a trade-off. I will talk this later in the presentation, but in any case, you can still have useful information with anonymized data. Okay, maybe you don't need to know that I'm in PUC now, but you know that I'm in Gavea. Okay, so still depending on the analysis that you need to do, could be enough for you to know that I'm in Gavea, not at PUC. So if the anonymized trajectory from PUC generalized, I'm in Gavea or I'm in Rio, okay, could be enough for some analysis. I don't know if I'm answering your questions.
No,
No,
okay, you
not.
answered the question, but I'm looking forward to the point you mentioned later on the seminar, because I think you will explain in more detail.
Okay, I will not go into detail of privacy in particular, but let's see in the end maybe if I'm answering or not.
Okay.
So
okay.
essentially the point is that with anonymization, there are different methods to anonymize, okay? But essentially what you get is another data set where you cannot recognize the person, okay? But still, depending on the analysis, you can still use the data for the analysis, depending on the analysis. So if the analysis is, I want to know exactly the point, then it's not possible. If I need some more origin destination analysis or something like that, maybe I can still have the useful information after the privatization, the anonymization. That is the point. I don't know
Okay.
if still answering. Of course, with the private, I cannot obtain exactly this picture. That's why when I present these pictures, which is a vision. It's not something that is probably we never have. Okay, it's just to make you understand the point. But of course,
Okay, now
so
this
maybe
makes
Google
sense.
have this data, just to rephrase. Maybe Google have this data, okay? Because with Google knows everything about me, okay? So probably Google have this data, exactly what it is here. But he cannot share with other person because it's privacy sensitive. So what Google will share is anonymized version of this. Okay.
Okay.
And then depending on the kind of anonymization, the kind of analysis we want to do, some analysis will still be possible with anonymized data, and some analysis will not be possible. But this is a trade-off we have to accept because of the privacy. No, not answered yet.
No, yeah, you answered it. It's just that I think I imagined something like a bit utopic, a bit different from the reality, and I just said, okay, it's just an example. In reality, you can enrich in other ways, and now it makes more sense to me.
Okay, let's go. And then at the end, if you think that I still haven't answered, I can go more in deep on the privacy. I don't have slides on the privacy, but I can I can explain what I know about privacy. Okay, so about the projects. So yeah, by the way, one of the Brazilian PhD student I was mentioning in the beginning, she's working exactly on privacy of this kind of trajectories, just for you to know. So it's something that we are aware, and we want to try to understand what we can, what is the part of multiple aspect trajectory that is more, let's say, a danger for privacy, what we can keep, what we should remove, and which kind of method we should use to try to preserve privacy and utility. There is no answer about this, okay? There are a lot of approaches. Okay, so let's go. RTF. Okay, so another point that what time is it? We are on time, no? Yes. So something that we also working on multiple aspect trajectory about the management of this trajectory is summarization, okay? So here we want to, again, combine movement data with this complex semantics, and this combination tend to produce, depending on data set, huge amount of this data. Imagine combining all my trajectory with all the possible aspects, tend to produce a huge quantity of heterogeneous data. So what we were thinking about is try to simplify this data, try to summarize. And this is the work that is cited here. So essentially, what we did, we try to do the other way around. So far, I always say that we enrich the segments of the trajectory. So I put a stop, I enrich with the hotel, with the location, the bar, the restaurant. I put a move, I enrich with transportation may, and so on. Here in this approach of the summarization, we do the other way around. So we take the map of the city. Here is San Francisco, for example. I think it's San Francisco. We produce a grid of this spatial area. And then we take a cell and we enrich with all the semantic information we can extract from this cell. For example, here in green, we see that this area with this stuff for OpenStreetMap, for example, there are a lot of free open data source that you can use to do this action. For example, we discovered this area is mainly shops and industrial. So we semantically enrich the cell, the area. And then we merge together all the areas that have the same semantics. Okay, so if you have 2 or 3 more cells which are shop industrial, they become the same area. So what happened is essentially this kind of colored square here. So each color is a kind of semantic information that we have of the city, of this area. So these are the 3 steps that are listed here. Math tessellation means to create this grid, okay? Could be square, could be hexagonal, can be everything. We added the semantics to these cells. And then we merge all the cells which are exactly the same semantic. For example, shop industrial. Okay, this is the point 1 of summarization. So we put together all the part of the city which are the same semantics, where semantics in this case is the label of the land use, for example. And then what you do, we take a trajectory, go back to the trajectory. For example, here, see a trajectory that is transversing these areas, okay? So this trajectory passed from area B to area C to area A, okay? So essentially he passed from, which is food, drink, pedestrian, residential, is a kind of area, goes to education, food, drink, pedestrian, residential, and goes to shop industrial, for example. So what do you do? So we map the trajectory with these areas. We give a weight based on how much time he spent, this trajectory spent. So he stay most of the time in area B, it means that it was very interesting for the person in area B. If he stays short in area A, it means that was only passing through. And then we summarize again. So we merge the semantic location based on the similarity. So we have a similarity function that say that education, food and drink, pedestrian, residential is similar to food, drink, pedestrian, residential. So B and C are very similar, for example. So we merge. So we are simplifying this trajectory. So we start with the original trajectory that you see here with the green, the blue points here, to something that is very simple, because say B and A. So the trajectory passed from B and A. So we have a summarized version of the original trajectory based on the semantics of the area. Very simple. It's very simple, but it's very effective. So what we did, here I'm simplifying a bit, okay, from the paper, just for you to understand the idea. So what we did is to evaluate. So we say, okay, it's very, very simple. Okay, we started with the trajectory X, Y, T, very detailed. We go to B and A. Okay, so we are missing everything. We are not missing everything, because here in the experiment, what we did, we compare this method with some state-of-the-art methods like RLA and the SEXCAN-D. Believe me, just state-of-the-art. They summarize trajectories. And then we want to measure two things. One is how much is summarization rate, so how much more compact is the representation of the trajectory in terms of space occupied by the representation trajectory. But we also want to have a measure of how much the semantic is preserved. So we want to keep the semantic as much as we can. So it's okay to lose the points, but we want to preserve the semantics. Again, we can go back to privacy. Okay, could be a way to preserve the semantic, but privacy aware, because we are losing all the points, the specific points that tell us that Chiara is in POC now. We only say that Chiara is an area with universities and parks, for example. Okay. So we have these two evaluation measures. We took two open source free data sets. We downloaded the semantic information from OpenStreetMap. And what we observe, again, it's very simplified here, but just for you to know, what we observe that in terms of summarization rate, so how much compact become the trajectory after the transformation is most similar to the state-of-the-art SEXCAN-D, whose objective was to compress the trajectories. Okay, so we have more or less the same performance of other methods in the literature. That is good. It's not exceptional, but it's good. So we are not losing in terms of summarization rate, how much we are summarizing. But what is important is that we preserve the semantic much than the state of the art. So in these methods, we are not losing in terms of summarization rate, but we are gaining a lot in terms of semantics. So what you see in mutas here, don't worry, it's just a similarity measure in terms of semantics of the original trajectory with the summarized trajectory. So we compute the semantic similarity. And we discovered that with our method, we preserve the semantic similarity much more than the state-of-the-art method. And so we were okay, because we want to preserve the semantic and have a complete representation of the trajectory, but not losing the semantics. And this could be a way to say that the data is still useful, depending on the application, of course. Any questions so far about this? I know that it went very fast. In the paper, you can find all the information if you're interested. But I think what I hope is that the idea, the overall idea is clear. So we take the multiple aspect trajectory that could have a privacy issue, big data issue, and so on, and we try to extract what is the most important part of the trajectory in terms of semantics, and try to measure if this extraction, this summarization is still valid. So could be a way to make a private trajectory, but at the same time preserve the semantics. Questions? Okay, last part. How can you infer? You remember the research challenge? We say how we can. One of the challenges was how we can create and manage a multiple aspect trajectory, and we say MathBuilder is one of the way to create this multiple aspect trajectory. MathSum is one of the way to manage this multiple aspect trajectory in a way that we can keep the semantic information and get rid of all the spatial temporal detail we don't care. Research challenge number 2 is how to infer interesting knowledge. It's not the only work we had, but here in this specific case, we want to see how we can infer human mobility dynamics from the summarized trajectory. Okay, so again, we can go back to the privacy. So if the information we retain after the anonymization is still useful, depends on the kind of application. In this case, what we wanted to do is to use the summarized trajectories to see if we can still compute some behavior. And this behavior in this work we chose is routine and non-routine. What is routine and routine? I asked again ChatGPT to help me in the definition. So he said routine behavior refers to action or activities that individual system perform regularly and predictably. predictably. Often as part of daily habits or established patterns. This is very important in the sense that the routine, to know the routine, not only mobility, I would say in general, but in mobility means to be more predictable, and more predictable is more optimization, okay? For example, the classical example, improvement on transportation mean if we become more predictable. So we as human beings have been proven to be very predictable, okay, in our mobility. If we can say extract to understand which are the person, the individual, or the part of the time we are more predictable, I mean, we can have more optimized methods, for example, for Uber, for transportation, for safety, for health, and so on. So to find which part or which person or which part in our routine is more routine and less routine is important. So what we did, we want to prove that sum. So the method to summarize aggregating the cells where the trajectory is passing through is useful to compute routine and non-routine. So again, the ways we are getting rid of the trajectory, we keep the semantic information that is essential. We prove that we have a good summarization rate and we preserve the semantic. Let's see if it's useful in a real application. So what we decide to do is to focus on this routine and routine. And essentially we define the regions, this A and B that you see colored here. We classify the region based on the relevance for the user. So how much time the user stay in this area. So essentially, if in the total visit of the area, I stay 90% in this area, 10% in this area, the first area is more important to me. If I now analyze my trajectory here, I stay all day in Puc and then the rest in the house in Plaza Osorio. These two places are more important to me than, I don't know, passing through Leblon that I just passed through, okay? So this means that we can classify these areas we define in these 4 classes. So significant, for example, I stay here 6 hours, so it's very significant out of 12 hours. Transit, I only pass through Leblon, coming here. Sporadic, from time to time I go to the supermarket, for example, or insignificant. So essentially I don't go, I go for a very, very short time. And then we measure the fact that these are routine behavior or non-routine behavior based on the entropy. So essentially, the entropy of the area in my trajectory is high entropy, is very intuitive. It's a non-routine behavior. So if my behavior, my trajectory here, it passed through several different areas, essentially is high entropy, so it's a non-routine, so I don't go every day to the supermarket, for example. A low entropy means routine behavior. Again, all the details are in the paper. I don't want to bore you more than necessary, but just for you to give the idea. So we are simplifying the trajectory in a way that we can see which kind of application can still be useful with the super simplified trajectory. And this is an example. So we can start routine and routine behavior. What we try to do to prove that in the paper is that we try to compute routine and routine in the original dataset, original row trajectory, all the points. We keep all the points, original trajectories. And then we compute with the summarized trajectory. And what we notice that essentially, apart from some misaligned user, for most of them is working well. It means that if we tend to preserve the semantics, we are still getting rid of all the details about the specific point. We are still good in identifying this routine and routine behavior, okay? Here there is some formula about what we did in the paper, so don't worry about this. For example, here there is a tag cloud that says significant location for me, for example, is residential, public transport, health and beauty. So there are some users that are classified on this kind of semantic information and other locations that are more transit locations. So you pass through So bicycle route, residential, natural, and so on. So it's nice because it's explainable somehow. So you can see the different area and what is in the area and how they are classified in our method. Question about this, or I can go through the last part. Okay, we will have time for the question also at the end, of course. So mobility data sharing, so mobility data in general, there are several issues, okay, not only for the sharing. One of the issue is that we don't have this data. Someone has this data, so mentioned data collector, Google, Uber, whatever. But then in some cases, us as a researcher, but also municipalities or other companies, they don't have access to the data. So data sharing, this effort that the European Commission is putting on data sharing is a way to try to mitigate this problem. But nowadays, the reality is that I cannot access data of Google, okay? I cannot access data of Uber, no way. So what, of course, one is the privacy that we already mentioned and discussed a little bit, confidentiality, also sometimes technological requirements. So I cannot collect all the data that Google is collecting. Okay, so we need Google to collect all the data, but how to access this data is another problem. Also, something that I want to mention is that collecting and sharing mobility data is not only problem with privacy, can also be biased. Sometimes, depending on who collect the data and how the data is collected, we can have some biased data. Biased means that is not fair with the different groups. For example, I'm exaggerating now, but if only rich people has the iPhone and only we can collect the information only from the rich people, we don't have any information about mobility of poor people. And this, if we have take some decision about the buses, of the tram, of the metro, of the Uber, is not fair because we are not considering the whole population. So all these kind of issues with the data sharing issue we already discussed make the research in the last few years to think about which could be a way to mitigate this issue, apart from convincing the collector to share the data. Another possibility is to generate the synthetic data. And then, of course, we talk about generative AI. You are more expert than me about this, okay? So what we ask ourselves is, can we use generative AI, so language model tools for generating synthetic data, mobility data, and mitigating this issue? Again, I asked GPT, my friend, and he say in one of the points, one of the lists, yes, you can use for synthetic data generation. And he say you can use generative adversarial network, GAN, variation autoencoded, blah, blah, blah. And especially, as I already say, it's especially useful for privacy. So if there is a way, no way to share this data because of privacy of the individual, we don't want to anonymize this data, or maybe the anonymization method is not sufficient safe, because sometimes it's not, even you anonymize, it's not completely anonymized, let's say. So sometimes it's better just to synthesize this data. It's okay, it's not referring to any real individual, so we don't care about privacy. Can be used for data augmentation. Data augmentation means to add more data when we are few data. So if we have very few trajectories and we want to implement some deep learning algorithm, run some deep learning algorithm, we don't have enough data to have useful result, we can generate this data from with a generative AI technique. And of course, simulating new scenario. So if you want to have an hypothesis, what will happen if we happen if we add a new metro in Rio de Janeiro, for example? Then you can synthesize this data in a hypothetical situation. So you don't have the real data because the situation is not real, but you can, let's say, simulate this with the generative AI techniques to generate this data. Okay, I think I already said this. So generative AI is used, is going to be used in this period, these few years. to produce synthetic mobility data, that is the trajectory X, Y, T can be produced with a generative AI technique. I found this nice survey here. You can find the slide later if you are interested to have an overview of this specific topic. GAN is more or less always used to generate synthetic mobility data. So which is the issue when you generate synthetic data? How you can invent this data is random? It's not random, okay? You can randomize a trajectory because trajectory should have a sequence in time that is reasonable. So essentially, when we generate a synthetic data set, we tend to keep some structural and statistical characteristics of the original data set. So we have the original data set that we cannot share for some reason, even with all the money of the commission, there's no way we can share this data, but we want to reproduce synthetic data that somehow keep the same structural and statistical characteristic of the original data set. And this new data set, since it is synthetic, we can share. But it's a different data set, okay? It's synthetically generated, but still preserving some structure and statistics. Remember structural and statistical characteristics. Because this means that we can still use for some analysis. Remember the data summarization. We summarize a lot, okay? There is nothing to do with the original trajectory, but still we could have some utility in the analysis. Here, the principle is the same. So we want to have a new data set that is completely different from the original one, but not completely, because we want to preserve some statistics that guarantee that our analyses are still useful, even if it's not the original data set. There are several methods in the literature for doing this. I encourage you to read the paper if you are curious. Essentially, which is the point, is that usually this synthetic generation with generative AI is used for text and image data. So what they are doing is try to adapt to the spatial and temporal domain. So under the spatial point and the time information. Again, this is exactly the slide that I was mentioning with your first question. So which is the trade-off between utility and privacy? Okay, so both utility and privacy should be achieved, but it's very difficult to find a balance. Okay, so who wins? We don't know. Sorry. So how we can evaluate the utility? So the privacy, there are many methods to evaluate the privacy. Another seminar, okay? Utility, how you evaluate the utility? Downstream task, so which application can be used to evaluate if it's still useful, okay? The example of routine and routine is exactly an example of downstream task. So we apply some method to anonymize in this case, or to summarize, or to generate new data, and then we see if the analysis task is still valid compared to the original data set. This is a way to measure. And another way to measure if the synthetic data is still useful is how different or similar is from the raw original data. So we define some measure of similarity of this data, and we measure, we say, okay, from this measure is quite similar, so it can still be useful. Okay, I think I already said that. Okay. So I will go to the conclusion, and then if I have more questions. So in summary, which is the message? Mobility sharing is a challenging issue because from one point of view, would be very important for the companies, for the municipalities, for whatever using mobility data to have access to different data sources. We can enrich the data in different ways and then give rise to new application and services that can be sold by companies. So there is a business behind this, but we need to solve a lot of issues, okay? One of the issues is privacy, confidentiality, how to integrate this task, and so on. Just to conclude, then we also discussed that generative AI could be useful to solve some of this issue, because it's a way to generate given an original data set, to generate a new data set that preserves some characteristics of the original one, so we can freely give the data set to someone else. No problem for privacy, no problem confidentiality, no problem for our business. But at the same time, we preserve some characteristic that makes the analysis useful. And of course, it's an open research direction. So there are a lot of papers nowadays about this topic, generative AI for mobility data. But so far as I know, there is no unique solution. It's very open to new discussion. And okay, you can find later in the slides all the reference. And I want to thank my colleagues that are working with me on this, Matt Builder, Matt Sam, and whatever, that is Francesco, Chiara, and Fabio. And if you have any question, I'm here.